Hey you guys, it's Professor Vitt, and we are going to go ahead and start up on our module for perceptual error and trickery. I had the garage all set up today. It was ready to go. Everything was beautiful, and then my neighbors started to jackhammer. I'm not joking. Gah, 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 gah. And I waited about 40 minutes. No, that's never going to end. So we're doing it from the kitchen. So I hope this is okay with you guys. Now, a couple of points. The title, Perceptual Error and Trickery. It's not the perfect title for this module, but it's okay. So we're just going to go with it, right? The very first thing that we're going to cover is something that some of you may have heard of already. It's called confirmation bias. Confirmation bias. Now, you see here somebody has a blindfold on and they're unable to see what they're doing, obviously, because they have on a blindfold. That is very close to what confirmation bias does to you. It is something that affects everyone. Every person has confirmation bias. The best that you can do is be made aware of it and then try to actively counteract the tendency you have with confirmation bias to favor your beliefs that you already think are true. So before I get rolled into it too much, let's just give a basic definition for what it is. Confirmation bias is when people count the hits but they forget the misses. So at its core, this is what it is. This is the most simple, distilled version I can give you. Generally speaking, people look harder for confirming evidence than they do for disconfirming evidence, meaning people want their theories to be ultimately true rather than false. So generally speaking, this is the tendency that our brains have to look for things that we already think are true and to confirm those things, but when we're presented with ideas that we don't agree with, we don't give it the same standard of evidence that we would expect in a rational person. So it's kind of a form of selective thinking. It's when you notice what confirms your beliefs, and then you ignore what undervalues or contradicts your beliefs. Let me give you an example, an analogy from The Wizard of Oz. So in The Wizard of Oz, Dorothy comes to the Emerald City. This is in the book. And before anyone is allowed into the Emerald City, which is the most beautiful city, right? Everything is green and so forth. Come on, Emerald City, here we go. Before she's allowed entry into the Emerald City, before anybody can get into the Emerald City, they have to put on glasses, and these glasses lock onto your face. And when people ask, oh my gosh, why am I being, why are these glasses being put on? People say, well, it's for your own good. It's to save you from the brightness and the glory that is the Emerald City. Now you might have already figured out what's going on here. The Emerald City is not any greener than any other city, but it only looks that way because people have glasses fastened onto their face that they can't remove while they're in the Emerald City. This is a great way to think about confirmation bias. Our confirmation bias makes us tend to think things are a certain shade or a certain way or have a certain quality when in fact they don't. So the absolute classic example of this is full moon and crime rates. So many people, many incredibly intelligent and very educated people believe that crime rates increase as there is a full moon. So I have a friend, she is a nurse in another state. She's my son's godmother. And she's a nurse, and I remember we were standing in line at Disneyland, and when you're standing in line somewhere, you've got nothing to do but talk. So I asked her, is it crazier in an emergency room during a full moon? And she didn't hesitate for a second. She said, oh yeah, it's nuts. We always know when it's coming. We look on the calendar and we circle it. Well, for years people thought this was true, and so a number of social scientists spent a great deal of time trying to verify this claim. Is it true? It turns out there was absolutely no evidence that suggested any correlation or any statistical significance to the full moon and the rate of crime. So the interesting question isn't, is there an increase in crime during a full moon, but why do people think so? Here's why people think so. Suppose you work in an emergency room. Suppose it is a full moon and you have a crazy night, right? Someone comes in with shotgun wounds, somebody else comes in with something else, and it's just a crazy night, right? A lot of crime-related illnesses or injuries. Okay, fair enough. Now, the next night is not a full moon, right? Because you get a full moon for one night. The next night is not a full moon. It's crazy, but you don't think anything of it. You are not going to think anything of the crazy nights between now and the next full moon. You'll dismiss them as just being a crazy night. But you remember the one that was a crazy full moon night from just last week. This happens over and over again, right? What the scientists are doing is they're looking at the statistics as to, you know, how busy is each night on each night relative to the full moon. But when you look at those statistics, there's no significance. So what's happening is the nurses and doctors who are super intelligent and have been trained for years to do this, when they have a crazy night and it's a full moon, they remember it. And they say, oh my gosh, of course this is a crazy night. It's a full moon. And then when the next full moon rolls around, they're going to keep that in mind. And 6-7 years down the line, somebody's going to say, are full moons crazy? And they'll say, oh yeah, because it's easier to recall those instances, right? They're counting all the cases where there's a hit. They're counting all the cases where there is a full moon and the emergency room is crazy. The nights where there is no full moon and the emergency room is crazy would tend to suggest that the full moon doesn't generate these high crime rates, but they don't recall those instances, right? So it's an idea like they're only remembering the cases where it was a full moon and a crazy night. They're not remembering all of the other cases. So that would be a case of confirmation bias. I'm going to give you a second example now, and this involves cards. Now these are called Wason selection tasks. The first one is going to be super hard. Bear with me. The second one, the beer drinking example, will be far easier, and then you're going to be surprised when I tell you why. So just work with me on this. By the way, I think I got this wrong many, many times. So just do your best to answer forthright. Don't try to make it too tricky. Suppose I have 4 cards in front of you here, A, D, 3, and 7. And suppose further that I have a rule that I want you to check about these cards. The rule is if there's an A on one side of the card, then there's going to be a 3 on the other. Each of the cards has a letter on one side and a number on the other. So if I want you to determine whether or not this statement is true, right, whether or not it's true that if there's an A on one side of a card, then there's a 3 on the other, then what cards would you turn over? Well, a lot of people say I would turn over the A and I would turn over the 3. The thinking is, if there's an A on one side of the card, then there'll be a 3 on the other. That would confirm, right, the hypothesis. And also, if there was an A on one side of the card and then there was a 6 on the other, then I would know that this rule is false. Fair enough. A makes plenty of sense. The next option that most people pick is card number 3. And they say, look, if I turn over this card, then I'm going to see whether or not there's an A on the other side. But do you notice that actually doesn't, the most that this rule could do, the most that turning over this card could do would be to confirm your rule. It would never disconfirm it, meaning if I turn this 3 over and there's a 5 on the other, or there's a B on the other side, this rule could still be true, right? Because the rule says if there is an A on one side of the card, well, there isn't an A if I turn over the 3 and there's a B. Right? So this will tell you whether or not the rule can be right. This could falsify the rule. This one could confirm the rule. There's actually one other card that you would need to turn over to determine whether or not this statement is true. And it's the 7. Okay. What? What are we talking about? Okay. This is how it works. The idea is if there was an A on the other side of this card, then our original rule that if there was an A on one side of the card, then there's a 3 on the other, would be false, right? So I need to turn this over to see if there's an A on the other side. Most people don't see that. And that's because their brain is wired, it is set up this way, to confirm our beliefs and not disconfirm them. In other words, we're looking for, when we're rolling through our Twitter feed, we're not looking for cases where someone asserts the opposite of what we believe, right? If I'm into the politics of the day, my Twitter feed is probably going to be filled with people that I already agree with saying things about the other political party that I don't agree with, and that makes me feel good and I'm on my way. But that's actually what we shouldn't be doing. We should look for cases where our beliefs are wrong, where our beliefs fall apart, and then revise accordingly, right? Now I'm going to give you another example here. This is a case involving you being a bartender. So imagine some fancy bar, and you've been hired as a bartender to keep people from underage drinking, right? So the rule here would be if a person is drinking beer, then the person must be over 21. So you have 4 people here in the bar. You want to make sure that you uphold this rule. Who among these people are you going to check? Well, you see someone drinking a beer. You don't know their age. Okay, you will probably check the beer drinker to see if they're over 21, right? You'll ask what their age is. If you see someone drinking soda, who cares? Nobody cares because they're not going to be in danger of breaking the rule. Now, if you see someone over 21 years old drinking and you don't know what they're drinking, you could check to see their ID, right? And if they were also drinking beer, then they would be okay. But the real person, and this is the person it's probably just jumping out at you, and you're like, can I fast forward until you get to this last card? The other person that you got to look at is that 17-year-old who's drinking, right? If they're drinking and they're drinking beer, then they're breaking the rule, right? So imagine it again. You walk into a bar. Person is drinking beer. Person is drinking soda. Someone who's clearly over 21 is drinking something. You don't know what it is. And there's a 17-year-old who's drinking. All right, you're the bouncer. Who are you going to check? Well, you could check the beer drinker. You probably should. You don't know their age. The soda drinker, who cares? Anybody can drink soda. Someone over 21 drinking, we certainly could check them, but if they're obviously over 21, then, they're not going to violate the rule, even if they are drinking. At most, they would confirm the rule. And then lastly, that 17-year-old, having been 17 years old, right, in these situations, you need to check them immediately, right, and see, okay, this person is not of legal age to drink. Now, the funny thing about this is that this is the very same problem that I gave to you before with the numbers A, D, 3, and 7. The difference is the context of the problem is the same. So is different. This is formally the same problem, but the difference is it's in a different setting. And when your brain is in a social setting, it does a little better than it did in the first setting. And the reason for this is humans have evolved in an environment where people who were able to detect cheaters did better, right? So groups of people who could detect people who were cheating within their group could expel those people or take some action to prevent them from cheating, whatever the form that cheating took. It was probably usually food, right? That someone was taking more food than was their share or something like that. Our brain isn't perfectly rational. Instead, it's kind of spotty. And so even though these are the same problem, they are different to your brain because of the setting in which they encounter them. So this is just one more case where you can see your brain functioning differently. Your brain tends to prefer confirmation, but when I give you the same problem in a different context, it's just so obvious. Like, okay, I'm a bouncer. Let's see what the 17-year-old is drinking. But notice earlier when we were talking about these cards, and I said, okay, you'd flip over the A and the 3, right? You didn't obviously say, oh, turn over the 7, because that 7 might disconfirm our beliefs. It might prove the rule wrong. Well, they're the same problem, but the difference is how it all appears to your brain. Your brain is devoted portions of itself to working with other people, and it can solve those problems much more quickly than it can solve these problems, even though the problems are formally identical. Okay, let's move on to another example. This is one of the classics, Mary Toft from 1726. Wow, if she would have known she made it this far, that she was this famous, I think she would be very pleased. Okay, in 1726, Mary Toft, this is actually a contemporary drawing. I think this is an ink. I don't think it's a wood carving. Maybe it is. This is Mary Toft here, and then all these other individuals who were present or taken in by her scam. In 1726, you see Mary Toft here is in labor, and she is giving birth to a bunny. See, what happened was Mary Toft had convinced the King of England's surgeon that she had given birth to a rabbit. Now, you might say to yourself, well, of course, this is 1726. What do these people know? Believe me, these people knew full well that humans don't give birth to rabbits. The only thing that humans give birth to are other humans. And the only thing that rabbits give birth to is other rabbits. This was well understood. But what wasn't understood, at least until many years later, was why so many educated and learned people fell for her trick. Well, when we found out a little bit more about a medical theory that was prominent at the time, psychologists then discovered, oh, I see why she convinced so many people. So let's get into it. Okay, how did she do this? Okay. When the doctors talked to Mary Toft, she had a couple of very interesting things to say. The first thing she said was, I have to admit, during this pregnancy, I was obsessed with rabbits. I would look for rabbits in the garden for hours. I would play with them. I would feed them. I just couldn't get enough rabbits for hours on end, right? I had this absolutely overwhelming craving to eat rabbit meat. Just had to do it. Loved rabbit meat, ate it every chance I could get. Okay. These important points that she made related to a doctrine that doctors thought was correct called the doctrine of maternal impressions. Okay, what is this doctrine? The doctrine of maternal impressions was an attempt by doctors to explain why there were birth deformities, why people were born with deformities. So let me give you an example. So someone is born with a birth defect. And at the time, medical science was very limited. They didn't know about DNA. They didn't know about cell structure or anything like that. But they did think, it looks like this person has been badly beaten. And yet they were born this way. Obviously, this isn't an infant. Why? Why does this happen? Well, it must have been that at some point during the mother's pregnancy, she was attacked and beaten. And the force and the trauma of that beating then presented itself to the child. Likewise, if a child is born deaf, it must have been because the mother heard a very loud sound when she was pregnant. So you can see how, if this is already in the back of your head and somebody tells you that they had an obsession with rabbits and they ate lots of rabbit meat, at least in theory, perhaps you could affect the way that a child would come out. Right? I mean, if a child is deaf because the mother heard a very loud sound, similarly, maybe if a mother ate a bunch of rabbit meat and obsessed on rabbits a lot, maybe it would be possible to have a rabbit be born from a person. I mean, it would be miraculous, but who knows, right? And it's because doctors already thought that the doctrine of maternal impressions was correct, because they already thought that was right. Mary Toft seemed to confirm what they already thought was true, and so they accepted it without greater scrutiny. I'm not going to go through that way. The point here of the Mary Toft, by the way, this is not a completely... The doctrine of maternal impressions, although it's obviously not true, there is a significant relationship between the mother and carrying a baby. So if we know this, right? I mean, there are reams of data where we know that untreated gestational diabetes can have an impact on a baby who's born, right? Or if the mother is exposed to certain things in the environment through no fault of her own, those hazards could be passed on to a baby, right? So it's not like they were completely wrong about about there being a relationship between a mother and a baby, but they were wrong as to the exact nature of that relationship. Okay, so there's a couple of examples involving Mary Toft, and the idea was doctors were far more willing to believe this because they already thought that it was true because they believed in the doctrine of maternal impressions. All right, so next up to bat, I want to talk briefly about the backfire effect. In a perfect world, when someone tells you you're wrong, and you are wrong, right, they've demonstrated that you're wrong, you would revise your belief. But that we don't live in a perfect world. We live in this world. And in this world, when you challenge somebody's beliefs by contradictory evidence, you only make their beliefs stronger. They don't change their beliefs, they just double down on their beliefs. Let me give you an example here, or at least an illustration of confirmation bias. All of these blue boxes here are books that are bought on Amazon. So, Devil We Know, Patriot Grace, When Markets Collide, Hot, Flat, and Crowded, blah, 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 blah. Okay, these are all books. These red bits here, and I didn't condense the picture because then you wouldn't be able to see what this is. These are other books: Climate Confusion, End of Prosperity, Liberal Fascism, blah, 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 blah. Okay. The arrows between these dots are people who've bought one book and then they buy another. So Amazon knows that people who bought Loser Takes All also would then usually buy Way of the World, or Cracking the Code, or End of America. Right? But what never happens is somebody buys Snowball, and then after reading Snowball they go to Climate Confusion. Well, that never happens because all of these blue books are democratic, more liberal-ended texts, and the red squares are conservative books. So Amazon knows something very deep about human nature, which is we seek out confirming beliefs. So if I am conservative and I want to read a book about climate change, I'm probably going to read one on climate confusion because I already think that this is going to be closer to what I believe to be true. This has an enormously detrimental or bad impact on society. If you never learn the other side of an issue, you will never move forward because you will never understand your opponent's position or another faction's position. So it is extremely important, if you can do it, to try to diversify your media and diversify the books that you read. Read a book that you just absolutely don't agree with from beginning to end. It's hard to do. It's very difficult because you're fighting a tendency of your mind, right? But I want you to try and do it if you can. Challenge yourself on your beliefs. Seeing the picture as a whole makes you a better thinker rather than just spewing out one side of a debate, right, over and over and over again. All right, we're done with confirmation bias. Let's move on. Okay, on to another perceptual error. It's called pareidolia. And it is exactly what you think you see right there. Kind of. So what is that a picture of? Right, so it's a picture of a drain, a tub drain probably, or maybe a sink drain. But all around it, it actually looks like an eye, doesn't it? And you can sort of flip between, oh, this is a screen, oh, this is an eye, right? And you notice that when you see this as an eye, remember there's no ambiguity. You're getting this picture raw. This is a live feed, and somewhere in your brain it's saying, oh, by the way, this is an eye, right? This has been noticed by people in the past, the tendency of our brain to find patterns that are familiar to us. But there was never the clinical research or the modern methods that we have now to kind of hammer this out more finely. So this is a quote from David Hume. He's a famous philosopher. There's a universal tendency among mankind, he really means humankind, to conceive all beings like themselves and to transfer to every object those qualities with which they are familiarly acquainted and of which they are intimately conscious. We find human faces in the moon, armies in the clouds, and by a natural propensity, if not corrected by experience and reflection, ascribe malice or goodwill to everything that hurts or pleases us. Okay, there's a picture of Hume. He's noticing that we have this tendency in our minds. And what he's talking about is pareidolia. It's when the mind perceives a familiar pattern where none exists. So hopefully you can see this picture here. Stop and take a second. Ask yourself what it is. Most people see right here, it looks like a figure. Here's an eye and a nose, and then a beard and hair, right? There's a scalp line, right? And this looks like a picture of Jesus, or at a minimum, somebody who looks like Jesus, right? But when you really drill down on this picture, this is actually a couple holding a baby. Here's the guy right here. He's got a beard. Okay, this is his face, and now here's his shoulder and his arms going down underneath. This is like his lap, and the baby's sitting up. The baby's face right here is the same as Jesus's eye, and Jesus's forehead, or the person who looks like Jesus, has on. This is actually the baby's hood, right, instead of the forehead, and then you can see the other woman standing here. It's remarkable, right, to look at it. It seems unmistakable, that image. It almost looks like somebody superimposed something on top of it. Nobody did. It's an actual photograph. Here's another case of pareidolia. You can see, right? Oh, there's a clock. No, it's a face. No, it's a clock. No, it's a face. Here's another one. And when these pop up, I want you to think about how immediately your brain just registers it, right? You don't stop and go, okay, I see a circle and I see a color that accompanies the circle. Okay, this is a circle, and now I see brown. No, you just look at it and boom, it's a face, right? Sorry if that clap is too loud. Boom, it's a face. It just looks that way to us. That's how our circuitry works. Some of them are kind of funny, right? Now, why do we do this? Why does this happen? Well, turns out that it's one of the explanations for this comes from evolutionary psychology, which is a new field comparatively. But the idea is something like this. Look, our brains are wired to see faces because people who saw faces lived longer than people who didn't, even if it was only, a second or two quicker. So if we're out in the wild and I see a bush, if I can see the tiger's face in the bush 1, maybe 2 seconds or even half a second sooner, that might be enough time for me to get away. Whereas my compatriot over there didn't see it and they're eaten or they're taken away. It's somewhat conjectural, but it's actually not too far out, right? It would make sense because people who made false errors, people who saw faces where there was nothing, there would seldom, if ever, be a cost, right? There's not a cost for being overcautious. Okay, now, this tendency of our mind impacts how we think about other areas, and conspiracy theories are a great place to look for instances of things like this. Now, conspiracy theory, I don't want it to be taken in a negative way. It's just a term to indicate a group of people. It does have a negative connotation, but I don't mean it that way. Another way that I could refer to it is as conspiracism. But it's let me give you an example. It'll be better. So in 1963, this individual, John F. Kennedy, was shot and killed. This was on November the 22nd. And I won't show you the assassination video. There is one. It's awful. But there were lots of photos taken that day. The president was in a parade, and he was shot in a car that was open to hundreds of people watching. And so there were lots of photographs of people and the location and everything happening there. This one photograph is a very famous one. Now, it looks like there are two people sitting down here. Tough to say what gender they are. Probably this is a man or a male. Probably. Don't know here. But if you look at this picture, most people, I think, would say, gosh, this is just a blurry photo. I can't make much out of it. But if you look very closely, right here, it looks almost like this is a person who is talking into a radio like this, and the antenna is coming up behind him like this. Now, Jim Marrs, who is a conspiracist with regard to JFK, so he thinks that there was a conspiracy, there was a group of people who got together and killed the president. He thinks that this is a radio that someone is holding, and it's evidence that there was a conspiracy to shoot the president. Now, before I told you about this picture, before I went into such detail, I think most of us would have just said, yeah, that looks like a blurry picture. But then when I point out this could be an antenna and this could be, right, then you kind of see it. It's important to remember, even though this isn't a terribly convincing photo, even if you saw a picture, even if this person was holding a radio or something with an antenna, that in no way strengthens or establishes the claim that the president was assassinated. It just means you have a picture of somebody holding a radio. Period. What are they doing with the radio? I don't know, listening to it? Does it have to be a two-way walkie-talkie? I mean, this could just be a radio that someone's carrying. But realize that for the conspiracy theorists, this is a hot piece of evidence, right? This is exciting because of how our brain works. Remember, your brain just gives you the pattern. It doesn't tell you there's ambiguity. It doesn't tell you, well, this could be a branch, this could be a rod sticking off of a building, this could be any million of things, right? Any number of things. This could be a lunch pail this person is carrying, right? The ambiguity doesn't appear in your perception, right? It doesn't look like it could be something else. When you really strain and look, it looks like it's a radio. So Jim Marrs is looking at this and says, gosh, I'm showing you a photo that establishes a conspiracy. How could you deny it? And your brain is saying, well, I'm not seeing this pattern, but his is, right? So it can actually start to really tweak and destroy the way that people look at evidence. Our brains are just very good at finding patterns. And so they find them in all sorts of places. This is another picture here of the fateful day where President Kennedy was shot. Here's Kennedy here. He's slumped over. This is after the first shot. And his wife is holding him. And there is the conspiracists maintained that, at least some of them maintained, that up here, that the shot that killed the president, you see him sloping down here, came from this location. Now, the government did an extensive investigation and found that the shot that killed him came from behind him on the school book depository. There's lots of evidence to show that that was true. But nonetheless, right, despite medical reports and so forth indicating that the nature of the wounds was such that Kennedy was shot from behind, despite that evidence, people persisted and said, no, the president was shot from the front. Now, there are reasons that people think this. We don't have time to go into them, but what we're going to look at here is the pattern that interests people. An individual begins to look at these smudges and says, hey, I see a person right here with a badge pretending to be a police officer. And this is a blow-up of the person with the badge, right? So this is the blow-up of that area. And JFK conspiracist felt that this showed that there were people standing up there behind that grassy knoll, and they shot the president. So here's the picture. Here is the colorized version. You see, here's the badge man right here. It looks like he's almost got a whiff of smoke from his gun or something. Might be dressed like a police officer, maybe with brown hair and face, right? You can almost see the eyes. You see someone standing here. Somebody else here, maybe talking on a walkie-talkie or something, who knows. Now, this is the black and white. This is the color. And you see the pattern? Now, most of us would look at this and say, this is just a blob of stuff. I mean, this isn't anything at all. But once I point out the badge man, see, you can kind of see him. Here's his hat. There's a little smoke or spark. And this is his chest and torso, right? Now, remember, the conspiracist sees this and says, oh my gosh, there's literally the smoking gun. But somebody else who doesn't have those same expectations, they don't see it, right? And so Pareidolia, it's one of those things just to refresh you. Your brain is going to fool you, and it's going to do such a good job that you won't know. And so this is just one of those cases, right? It's just one of those cases. Here's another case of pareidolia. I think it's a good one. This is a picture taken on 9/11 when Flight 77 crashed into the Pentagon. So there's a lot of controversy around 9/11 as a conspiracy theory, and we don't have time to look at all aspects of the theory. So I'm just going to look at one specific event here on 9/11, and this was when this flight crashed into the Pentagon. And you can see here some of the wreckage of the plane having been thrown from the explosion. And present in this photograph right here is a bit of yellow. So you can see this is the wreckage, and the yellow is right there. Now, a theorist who is a 9/11, what you'd call a 9/11 truther, so someone who thinks that the American government had a hand in orchestrating or conspiring to execute American citizens on 9/11, right? So they think it was an inside job. And this theorist's argument was that the yellow portion here of this plane wreckage is a withered vine from a jungle in South America. And this particular piece of wreckage was taken from South America and transplanted here to Washington, D.C., moved thousands of miles and placed here to make it look like a plane hit this building and not a missile. Now, the problem with arguing that this is a jungle vine is that, well, it's not clear to me that this is a jungle vine, right? But the theorist's brain is giving them this, like, oh, this is a slam dunk. This is a green vine. Well, apply Occam's razor for a second. What's more likely? This is a piece of insulation which we know already exists and is found in planes and was found in this plane, right? Or this is a vine that somebody has transplanted for thousands of miles, right? They took all this time to move the wreckage, but they never thought to take off the jungle vines. Yeah, that seems unlikely, right? The more simple explanation is that this is insulation. But the brain of the conspiracist is more likely to jump to that explanation that this is a jungle vine because it fits with their, right, with the preconceived notions of what's happening. And these are just little snippets where you can see, right, there's much more to this debate. I don't want to give a postcard and say, oh, Professor Vitt, totally, right? I'm not here to debunk it. I'm just trying to give you an example of a case where, you have this stimulus and it's kind of ambiguous, right? People are looking at this splash of color and they see a pattern. But at it has more to do with their expectations and their brain finding patterns than the patterns actually being there. Okay, another example of this is Maria Rubio from 1977. So I believe she was cooking in her kitchen and she was making a tortilla, and the burn marks on the tortilla came through loud and clear as her Lord and Savior, right? Jesus Christ. And so she saved the tortilla and it became a national sensation, and people would actually come to go see it. You could go visit a shrine that I think was in the back of her house. But the point here is, right, we can all look at this picture and see, oh yeah, that, maybe that does look like Jesus. And when we look at it, there's no ambiguity. We can see the pattern. Now put yourself in Maria Rubio's position, right? It seems like it is just a picture of Jesus. There's no question about it in her mind. And so this is how Pareidolia works, right? It sees the pattern and convinces you that it's real before you've been able to establish whether or not it's real. Now, was it really a picture of Jesus? We're not here to address that. It's sort of like a philosophy of religion question. But the important point is you will encounter people who may see signs and so forth, or they may interpret things a certain way, particularly visually, and it's going to be extremely difficult to try and convince them that what they're seeing isn't real. And that's because the brain gives them all of the impression at once. It doesn't give them the underlying ambiguity. Oh, this could just be a burn mark or it could be a face. Your brain doesn't do that. Your brain goes, look, it's a face, right? So keep that in mind with pareidolia. It's very, very strong cognitive bias, and it tends to overthrow otherwise even the most skeptical of thinkers. Okay, so just show some fun here. You can see some pareidolia. Potato! At least it's a happy potato. Right? Pareidolia. Not all of them are stupid. There's a running question here between folks. What is this? So some of my students say this looks like two seahorses or something talking. Somebody else said it was two angels. And then the all-time was somebody who said, oh no, this isn't two people. This is one person. Look, he's got eyes and a mustache. Maybe he's sneezing. You let me know what you see there. There's another one there, if you can see it on the glass. All right. Now, speaking of faces, we are going to talk about another famous example of pareidolia, and this portion of the presentation is called Why the Face. I have a lot of students who use this in text messages or whatever, emails and stuff. Hey, Professor Vitt, WTF, I'm emailing you about a quiz, and I'm cool. I mean, I'm not totally, I don't not know what it means. It means why the face, so I'm kind of the cool professor that way. No, I'm just kidding. That was a joke. I know this doesn't mean why the face, but that's what it means for us, right? Why the face. Okay. All right. Back in the day, in the 70s, NASA sent an explorer to Mars. It sent the Viking orbiter, Voyager, to Mars. And it took, this is one of the first pictures from Viking, it took over 100,000 photos of the surface of Mars. And it took this one. And when this picture was beamed back to Earth, was printed out, and a NASA technician was looking at all these, and he saw this picture and he wrote face along the bottom of the picture and then put it in a stack, and nobody saw it for years. Well, eventually this picture came to the public's attention. And the fact that NASA didn't disclose that they had seen a face on Mars was immediately cause for trouble. And people said, this is a conspiracy. The government, NASA, is trying to suppress its discovery of an alien civilization on Mars. And this got a lot of traction, of course, because this does look a bit like a face, doesn't it? Right? Now, at the time, the tech who looked at this said, oh, it looks like a face, but it's clearly not. It's just a play of light and shadow. And that was NASA's official conclusion for many years. But people weren't always willing to accept that conclusion. And so this is an enhanced, modern picture of this. And it's been enhanced, by the way, to kind of make it look a little bit more like a face. When theorists saw this original picture, they formulated something called the Sidonian hypothesis. And the Sidonian hypothesis is named after the Sidonian plateau where this picture was taken on Mars. And the idea is that there was an advanced race on Mars, and for some reason they died off, but they left remnants of their civilization that we could detect, right, in some publicly demonstrable manner. And so researchers began publishing pictures of maps, pictures of the Sidonian plateau, and they would say, look at this right here. I have a pyramid structure here, and there is a perfect straight line between the top of this pyramid and the eye, or the middle of the face, on this rock. Clearly, this must be significant. Other researchers found an entire city, right? So this is a city square pyramid. There's a fortress, some type of rounded formation, little mounds, right? And then there's a little note here. So this is from the Martian Enigmas. The city is a collection of formations about 20 kilometers southwest of the face, blah, 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 blah. Okay, so lots of people are looking at this. They're seeing these patterns. It seems to be very clear that that's what you're looking at is a face. And people ran with it, right? People developed all kinds of theories about the Sidonian plateau. Here's another classic. Now, let me ask you something. Is this a good argument? If I tell you that I see a photo in a face on Mars, that then I can conclude that there is a face on Mars, right? No, right? This is not a good argument, right? I mean, I can see a face here on the sink with a nose and eyes, but it does not then mean that there's actually really a face over there on the sink. No. There are fixtures that are attached to the sink and they look like a face, but they're not. It's not a face, right? It just looks like one. So the thing to notice about this argument is people are moving from, oh, I see something in a photo to, okay, so then it must be real. But just because you see something in a photo doesn't guarantee then that the thing that you see in the photo actually exists in the real world. Interestingly enough, this is not the first time that this has happened with Mars. Long ago, when telescopes were just getting off the ground, a little bit after that, they were able to see the surface of Mars very faintly. And the more that astronomers looked up at Mars, the more that they found canals. And as they looked at these canals, they appeared to be intelligently composed or drawn or constructed. Here's another researcher's version of the maps on Mars, of the canals on Mars. I want you to look and notice that these two versions of the canals on Mars are incompatible with one another, right? You couldn't have both, right? One of these people is wrong, one of them is right, or they're both wrong. Well, what's going on here? It is just pareidolia, right? They're given this kind of they're given this indescript stimulus, and on that basis they're concluding that, oh yeah, there really is this pattern here of things that's really there in the world. But what they don't understand is your brain is very good at fooling you, and it's fooling you when you're looking up there and you think you see these canals. So another example of this is is space itself, right? I mean, the space is massive, it's vast. And of course there are going to be figures or things that we see in the sky, whether it's a constellation or whatever, that look like something else. And so this is the Horsehead Nebula. It looks just like a horse. Now, we don't think that there's actually really a horse out there. It's right. This is a massive gulf here, break in the gas, but it looks like that to us, and so it's important to keep that in mind. That you're going to see things, you're going to develop an impression of data or visual image that may not be correct, and you have to be willing as a critical thinker to question that. Okay, very last Pareidolia picture. Don't know if you can see it super well. But this is actually happy face on the moon of Mars, and you can kind of see there's one of the eyes, and there's the eye, and there's a big smile. This happy face was going to be used in The Watchmen. It's actually in the very end of the movie, and the director said, when they asked him, why didn't you feature it more prominently in the film, he said, well, I thought everybody would think it wasn't real because it looks so good. So, a little something to think about, right? Okay, I hope this is helpful. It's a shorter module because you have other stuff this week. You have your project going. But best of luck on the quiz, and email me if you have any questions or concerns.